What we're going to look at today is solving quadratics by factoring. So we're going to use some of the techniques that we used earlier in this section to factor, but now we're going to ultimately solve these expressions. So to go ahead and do that, really the first thing you want to do is go through the factoring process in our mind. So if I look at this expression here, looking at it, there's no GCF that I can remove from each term. So I'm going to move on to my next piece, and I notice that I have a trinomial with a equal to 1. So I'm going to go through my process for factoring that, finding two numbers that multiply to -12 and add to 4. So just again, from looking at this, I should know I have a negative at the end. I should end up having x plus some factor and then x minus another factor. So looking here, when I take a look, I list out the factors of 12, or -12. I should have -1 and 12. -2 and 6, -3 and 4, and then I can go the other way, -12 and 1, -6 and 2, -4 and +3. So I'm going to go through and look to see which of these add up to +4. In this case, it would be -2 and 6. So I would have x plus 6 times x minus 2, all of that equaling 0. Now, my process is not done because I just factored. It's asking me to solve. I need to figure out when this statement is true. I got it done in Algebra 1. Just find out what x values make this true. So what I need to use here is the zero product property. What that tells me again is if I set both of these binomials equal to 0, those are going to be the x values that make this statement true. So I'm going to set x plus 6 equal to 0, and then I'm going to set x minus 2 equal to 0, and I'm going to go through and solve both of these. Subtract 6 from both sides, I would have x equals -6. Add 2 to both sides, I have x equals 2. Those are the two solutions that would make this true. And if I plug them back into the original, I would see that I would get a true statement. I would get something equal to 0. And really what I want to do through the rest of these is the same process. Factor first, and then find out what x values, or in this case, t values, make this true. So here, if I look at this, I have a GCF. I can remove a 6 from both of these. So I would have t squared minus 36t equals 0. What I also see here is I can remove a t from both of these. So I could say 6t, and when I remove a t from this, I would have just t left over. When I remove a t from this, I'm sorry, that should be actually 6t, not 36t. I apologize. When I remove a t from that, it should just be left over with 6. Now, looking at this, there's nothing else I could factor. There's no t squared terms. I already removed my GCF of t, which kind of got rid of the t squared. So now from here, all I have to do is use the zero product property and set both of these terms equal to 0. What a lot of people forget is setting this term equal to 0. We have to set that term equal to 0 as well. It's all of the terms. Whether it's, in this case, we had two binomials, we set them equal to 0. This one we have one term here, another term here, we have to set those both equal to 0. So what that tells me is if I plug in t equals 0, or if I plug in t equals 6 into my original equation, I'm going to get a true statement. I'm going to get 0 as my output value. Now, these last two. Looking at this one, 7y squared minus 4y minus 3 equals 0. Looking at this, I have an a value that is not 1. I have a trinomial here, so I want to go through my process to go through and solve this. To do that, remember, I have an a value of 7. Multiply a and c together. Y squared minus 4y minus 21 equals 0. I multiplied a and c, but remember this a equals 7 is going to come back. Now I go through and I factor this. Again, my variable is y. We have to be careful about what our variable is. Y equals 1. We're looking for two numbers now that add to -4 and multiply to -1. My signs should be opposite. My sign should be opposite because I have a negative sign at the end. What that ends up coming out to is y minus 7 and y plus 3. Now, we bring that a value of 7 back into the picture. Remember, from here we would divide each of these terms by 7. What this side reduces to? Y minus 1. What this side reduces to is nothing. 3 over 7 can't reduce anymore. So the 7 should move into the front. what I'm left with here, y minus 1 times 7y plus 3 equals 0. Now I go through the zero product property. Set this equal to 0, set this equal to 0. Y minus 1 equals 0, and 7y plus 3 equals 0. Here, I add 1 to each side. I get that y equals 1. That would be one of my answers. In this one, I have to end up going through 2 steps. Subtract by 3, and then divide by 7. So I would have negative 3 over 7. So my 2 solutions would be that y equals 1 and that y equals negative 3 over 7. If I plug those into my original, those would give me true statements. Now, the last one. The issue here is the only way we could use a zero product property is if we have everything on the same side and we set it equal to 0. Hence the name. If it's set equal to 0, then I can end up setting the parts on the left-hand side equal to 0 and solve. So the first step I have to do is add 15 to both sides. I would have x squared plus 9x plus 20 equals 0. Now it's just factoring. I look at this, I have a trinomial where a equals 1. So I'm going to look for 2 numbers that add to 9, multiply to 20. That would be 5 and 4. And I go through and use the zero product property now. Set that equal to 0, set that equal to 0. X plus 5 equals 0, x plus 4 equals 0. Subtract 5 on this one, I would have x equals negative 5. Subtract 4 on this one, I would have x equals negative 4. Those would be my 2 solutions here, the 2 x values that make that true. Now, just one quick last example. When we find the function's zeros, when we find a function zeros, all that's saying is we're looking for our x-intercept, or whether our function equals 0. So all we really do is we just make y equals 0 here, and we go through the same exact process we have done throughout the entire rest of this problem, or all the rest of these problems. So looking at this, we have a trinomial where a equals 1, so we should be factoring this into 2 binomials. Alright, our variable is x. We have a subtraction sign at the end, so we should have a plus and a minus here. We are looking for 2 numbers that add to 2 and multiply to negative 35. What that ends up being is positive 5 and, I'm sorry, yeah, backwards. Positive 7 and negative 5. Alright, x plus 7, x minus 5. Those are going to be our answers for the factoring part. Now I can go through and use the zero product property, set them both equal to 0, x plus 7 equals 0, x minus 5 equals 0, and go through, get that x equals negative 7 and that x equals 5. And those would be our 2 solutions there. Oh, sorry, you can't even really see it there. But those would be our 2 solutions for these.